So you may have evaluated a 2 by 2 determinant now, and a 2 by 2 determinant has a relatively simple formula. Unfortunately, a 3 by 3 determinant, or a determinant of a 3 by 3 matrix, is a little bit more complicated. And I'm actually going to show a popular algorithm used in calculus to evaluate a 3 by 3 determinant. And that popular method is called cofactor expansion along the first row. It's called cofactor expansion along the first row. I'm going to illustrate a few examples here. I'm going to probably do a couple of examples, and then I'll ask you to pause the video and you try to do the last two examples, C and D. And let's get started. So this algorithm, or this method of evaluating a 3 by 3 determinant, has to do with cofactor expanding along the first row. So I recommend with your pencil, lightly circle the first row. And we're going to remember how to manipulate this expression in this form. So why don't I highlight the numbers in the first row? And the first thing you're going to do is write 1. Oh, actually, I take that back. The first thing you got to remember is there's actually going to be a parity symbol on top of these. So there's going to be a plus, minus, plus situation for all of these. You're going to see those plus, subtract, and plus symbols again. So the first one is positive 1. So I'm just going to write a positive 1 right there. And then what's left is going to be a 2 by 2 determinant. So that's going to say positive 1 times the 2 by 2 determinant, 1, 3, 3, 1. Now you see that subtraction symbol there in blue? It says now to subtract, this time a negative 2, and then multiply by the 2 by 2 determinant, 2, 3, 3, 1. Oh, you might have to, let me give you a little bit of color here. There's a lot of 3's in this example. So you're going to have to see this 3 here and this 3 here. Can you see the 2 now and 1? And I'm going to have to reverse that now. Hopefully you got a chance to see that. You might have to pause the video and see that. I'm going to reverse everything because I can't leave the colors on. So I'm going to reverse it until I get the colors off. And if you're lost with the first 2 by 2 determinant, let me go back and give you a hint. Why don't I use this color? This one here, this 1 here, this 3 here, and this 3 here is matching with what? This 1 here, this 3 here, this 3 here, and this 1 here. If you need to, pause the video and make sure you understand what's going on. Now I have to reverse my steps. I'm going to take the color off. And then one more expansion for the last number in the first row. We're going to add a negative 3. So you add a negative 3. That just means add the opposite, right? And then what's left? What's the determinant that's left? Well, the determinant that's left is, let's use this color again, 2, 1, 3, 3. And I simply write that 2, 1, 3, 3. And put it right there. I I'm going to have to reverse the steps again just so I can remove the color. Now I'm going to write 2, 1, 3, 3. And there you go. So if you cofactor along the first row, and remember that the first row has these parity signs, positive, subtract, and positive, or positive, negative, and then positive. We end up putting those parity signs here. Positive here, negative here, positive here. In fact, the first one is positive. That second parity became subtraction. And that third parity became addition. So just remember plus, minus, plus, plus, minus, plus. And then you got to remember to put the, what we call our cofactors here. Oh, wait, those are not cofactors. Those are coefficients, excuse me. Remember to put your coefficients here. 1, -2, and then -3. Now it's not too bad. It's not too hard to expand from here. If you want to clean this up a little bit, you certainly can. You might want to write 1, 3, 3, 1, plus a 2 here, 2, 1, 3, 3. Subtract a 3 times what? A 2, 3, 1, 3. And of course, evaluate this. 1 minus 9 is -8, plus 2 times 2 minus 9. 2 minus 9 is what? -7. And then minus 3, 6 minus 3. 6 minus 3 is 3. And of course, this just, you're just evaluating the expression. -8 subtract 14, -22, -22 subtract 9, -31. So your expression in A got manipulated to be -31. I know this sounds a little bit weird. It takes some time to get used to. Why don't we try to do example B? Let's look at the expression in example B. And we're once again going to do cofactor expansion. I think I barely have enough room here to split my page here. I'm going to split my page here and tell you that I'm working on example B. Why don't I use a similar color scheme? Why don't I first use green? Why don't I split my page using green? Split my page here. Start example B right there. First thing I'm going to do is I'm going to highlight the first row so that you could have a better view of it. Once again, along the first row, there are parity symbols. It's going to be plus, whoop. Let's try that again. Plus, then positive, I should say. Positive, negative, then positive. Expand along the first row. So take your pencil, lightly circle the first row. And now we're ready to evaluate. So remember, I'm looking at example B. You actually have -4. It's equal to -4. And then what determinant is left? I'll try to highlight this for you. That 1, 3, 3, 1. So you kind of have to take like a pencil or your arm to cover up that first column. And then you'll be able to see that 1, 3, 3, 1. I'm going to reverse my steps so that the color goes away. And I'm going to write that 2 by 2 determinant right here. 1, 3, 3, 1. Now we're going to subtract. Subtract. Ta-da! And then what is our coefficient? Our coefficient is -2. And then what is the 2 by 2 determinant that's left? So if we're creating a t that goes through that -2, you should be able to see a -2, 3, and a 1 left. And there you go. That's the determinant that we're going to use. We're going to use that 2 by 2 determinant. Let me reverse my steps so the color goes away. And let's see here. Let's write that 2 by 2 determinant now. -2, 3, -4, 1. Finally, we're going to add a -3. But adding a -3, of course, means subtract 3. I'll go ahead and skip that step. On the next line, I'll write it on this line just to be clear. And then what is the 2 by 2 determinant left? It is going to be -2, 1, -4, and 3. It's that determinant right there. We're going to go ahead and copy that over to our new expression. -2, 1, -4, 3, boom. And the rest is just simply computing determinants of 2 by 2 matrices, or 2 by 2 determinants. Let's see what this is. Certainly could clean this up a little bit. -4, 1, 3, 3, 1 determinant, plus the 2 determinant, -2, 3, -4, 1, minus the 3 times the determinant, -2, 1, -4, 3. Now, the order of operations here says to do the determinant first. So we'll just leave that as a factor. Think of the determinant as parentheses here. How do you know to do the determinant first? You're supposed to see something like that. -4 times AD minus BC. So you want to do inside the parentheses first. So you got to do the determinant first. And we got 1 minus 9, which is -8. Plus a 2, do the determinant first. So -2 plus 12 is 10. And then minus 3. And what do we have here? A -6 plus 4 is -2. And what do we have left? 32 plus a 20, and then plus a 6. So we have, 58. Ta-da! That big expression at first is now simplified to a smaller expression called 58. All right. That was A and B. Are you ready to do C? You might as well pause the video and give yourself a chance to do C and D. Hopefully you tried parts C and D on your own now. And if you want to check your answer, the expression in part C got manipulated into -12. So you want to manipulate the expression in part C to be -12. You want to evaluate the expression in part D to be -14. So make sure you can get those two numbers. All right, until next time.